All right, let's do another projectile motion problem. In regards to what you see in class, probably along the more complicated side of questions that we might offer you, something kind of like this. Let's say you've got a cliff. Let's say you have a cannon or something, okay, and it's going to shoot an object, okay, up at an angle at some velocity. Okay, so let's just give us some random numbers here. Let's say that we have a 400 meters per second velocity, so pretty quick, an actual kind of cannon here. Let's say the cannonball leaves at 50-meter height, and let's say that my angle here is a standard 30 degrees. All right. Now, when we approach this, we've got a couple options. Okay, let's write out our initial givens. And what I mean by initial givens, just the givens that the beginning of the problem represent. Okay, so let's just write those up here. My x initial is going to be 0. I don't know what my x final is. I know my Vx is going to be 400 cosine 30. My Ax is going to equal 0. Okay. My y givens, I'm going to start us off 50 meters up. I don't know what my y final is. My V initial y is going to be 400 sine 30. And my V final y, once again, don't really know. And then my AY is going to be negative 9.8 meters per second squared. This is negative right here because my initial velocity in the y direction is a positive value at this point, meaning the ball is going up, gravity is pulling down. And so since gravity is pulling down, we have to compensate with one of the two numbers being negative. Okay. If the ball was traveling down, then we could just say, well, down is a positive direction and make both of them positive. But in this case, since gravity is pulling down and the ball is going up, we have a difference in sign there. All right. Let's go over, I'm just going to solve for several different variables. A common thing that you might be asked is, let's choose this one. Let's say, how high off the ground does the ball get, the cannonball? Okay. So we're solving, we'll just call this part A. We're going to solve for y final. All right. Well, we have two options here. We have two equations we can use to solve for y final. At least that come to me right off the bat. Maybe, who knows, maybe there's even more equations. But we got y final equals y initial plus VIY times t plus 1/2 AY t squared. Okay. Our only issue with this one is that we don't know what t is. Okay. We can solve for t pretty easy though. Now notice the defining feature of up here, of this spot, my defining feature of that spot is that my velocity in the y direction has gone to 0. So I can come up here, I'll just say for this part at least, that's going to be 0. All right. And so I can solve for time pretty easily using this equation. Okay, just my standard final velocity equation that's derived from my acceleration equation. Okay, I can make this go to 0, solve for t, and I can get negative VIY divided by AY. All right, let's plug that in. Let's do negative 400 sine 30 divided by, now notice here, because I've got this as a negative here, those negatives are going to cancel. Okay. Drop that in, you're going to get something along the lines of 20.41 seconds. All right. Then you can take this time and plug it in for your times here. So let's rewrite this equation. Let's go y final is equal to, my y initial is 50 plus 400 sine 30 times by my 20.41 seconds. I was thinking myself enough room there, didn't I? Okay, plus, we'll write this down here, 1/2 times negative 9.8. That's important you put that negative there. If you don't put that negative there, then what you're saying is when the cannonball leaves the cannon, that it speeds up as it goes up. And we know that's not the case, and so you got to be careful. Okay? So we can put that into our calculator. Well, I've got my calculator with me. Let me show you how to plug this in. When you plug it in your calculator, you can do it all in one step, but just make sure that when you square that t, you don't square the acceleration with it. So you're going to go 50 plus 400 sine 30. You can do another parentheses there for a 20.41. Okay, plus, I'd use 0.5 for 1/2. That's just easier for me. Okay, so 0.5. And then we got negative 9.8 times, and then we got 20.41, and then square that. And you get 20,000 or 2,090.8 meters. All right. Now you can do that, or so that's one option for finding y final. The other option is you can use this equation. Okay, this is the equation that we use when we don't have time. All right, so this is an option for you. Delta y is usually what we represent here, but I've expanded it out just to show you where the y final is coming from. Once again, at the top of the arc, okay, I've got 0 right there. So if I solve for y final, I'm going to minus the VIY squared over to the other side. I'm going to divide the 2AY over. And then I'm going to add the y initial over. Okay, you plug those values in, you're going to get the exact same thing. You'll get around 2,090 meters. Okay, or you could even round it to 2,091 since it's a 0.8. All right, so that's our, our A. Now let's say we have a part B here. All right, and we want to solve for how long it's in the air in total. Okay, meaning as of right now, we've only solved for how long it takes for the ball to go from here to here. We haven't solved for how long it would take for the ball to go from here to here, though. We have to add the two times together. Now, in this case, if the ball was to leave the ground and land on the ground, meaning it left and landed at the same elevation, then you could just take this time and times it by 2. But we don't have that case. Obviously, we could logically just assume that it's going to take longer to fall than it took for it to get up because it started 50 meters higher than where it's going to land. Okay, so what we do, real simple equation, we're just going to analyze this from this point on. We're going to break the problem in half. We're just going to find the time it takes to do this part and add it to the time that we'd already solved for earlier. Okay. Now this is very similar to a problem where we do, say we throw something off a table or we throw something horizontally. Notice right here, there is no vertical velocity at this point. The only velocity that's happening is just going horizontally. So I'm going to rewrite my givens. All right. My givens, my x initial still don't know. I'll just say it's 0 at our new spot. Don't know x final. Okay. My velocity in the x has stayed the same. So 400 cosine 30. My ax is still 0. And my y. Okay. Now my y. I'm going to state, because I'm restarting in essence, I'm making this a new problem. I'm going to state that up top here, that's my initial position. I like to start at 0, so I can just say, using my opinion, that that's at 0 meters. And that y final is the 2,000 and roughly 91 meters that the ball is going to fall from the top of its arc. Okay, so in this case, I'm stating that going down is a positive direction. Okay, notice at the top of the arc, the velocity is 0, and I don't know how fast it's going at the bottom of the arc. And my acceleration is going to be a positive 9.8 because the whole problem is going down at this point. To solve for time, we've got a nice, easy equation set up for us that we've used in class many times. That's the equation you want to use. Okay, so that's going to be the square root of 2 times 2,091 divided by 9.8. Plug that into your calculator. Don't forget to square root it. A lot of people forget that. Okay, so your t here is equal to 20.66 if I round. Okay, seconds. Notice the time difference between this and this are quite small. It's only 0.2. All right, but that 0.2 does make a difference. That's a difference of, where that 50 meters caused that 0.2 difference. So my t total, let's cram it in over here. My t total is going to equal 20.41 seconds plus 20.66 seconds. And you're going to get a grand total of around 41.07 seconds. Okay, so that's a t total. Another question we might ask, and we'll just flip this over, okay, is how far does it go away from the base of the cliff? So what's my x final? Well, in this case, x final, that's an easy one to solve because we have a standard equation for this. Okay, I know what my constant velocity is. My constant velocity is that 400 cosine 30. Okay, now this t right here, this is the total amount of time that the cannonball is in the air. So we'll label that t total, and that's going to be the addition of the two that we just had, right? We'll say at t1 and t2. That equaled our answer to number B, or letter B, and that's 41.07. Okay, so you times those two together. Let's see what we get. Okay, and you're going to get 14,227 feet. 0.1. Okay, or sorry, meters, not feet. This is in seconds. This is meters per second. The seconds cancel, leaving you with just meters. All right. So those are just a couple of things that we could do. Notice when you start this problem, okay, we're only given a height, velocity, and angle, and we were able to find out how long the ball was in the air, where it landed in respect to the base of the cliff, and how high off the ground it got. All right. We could keep going. We could even ask questions like, how fast is it going when it hits the ground? At what angle does it hit the ground? We can keep asking those questions. All right, but this is just an example of what we can do. Don't be afraid to rewrite your givens if you feel like it's going to benefit you. That's probably the number one thing I'd hope you take away from this example, is that it helped me rewriting my givens so that I could use an easier equation to solve for that other time. All right. If you have any questions, please let me know. Love to help you. Hopefully this video answers some questions for you. So.